Okay, this is video number 4 of 7. These questions are from the Florida B.E.S.T Instructional Guide that's provided by the Florida Department of Education. It's also called the Big M, that's this resource. And these are the standards that we are going to be covering. In this video, some of the questions are a little bit more challenging than the last couple of videos. So let's get into it. Describe the sequence of transformations that could be used to prove that the two quadrilaterals shown are congruent. So what we want to do is choose the transformations that would map one onto the other so you could prove they're congruent. Like if they were right on top of each other, they would be the same shape and size. So a 90-degree rotation clockwise wouldn't quite get it all the way around here. That would only be one turn putting the shape over here. Well, clockwise would be over here, but not quite all the way around. 180-degree rotation. Yes, I believe that is it. 270-degree rotation counterclockwise. No reflection over the x-axis, so x-axis would be like this. No, that wouldn't quite reflect it over here. So 180-degree rotation is our best answer, and that would map it right onto that one. The next question, triangles ABD and JKL. It says that angle A is congruent to angle J. Angle C is equal to angle L, and then AC equals 2 JLs. So AC and JL are not congruent, but they are related through a scale factor of 2. So let's see, we could rotate it, counterclockwise rotation and dilation. Okay, so if we took this and we rotated it counterclockwise rotation, and then we dilated it, but we'd have to dilate it so it gets smaller. So it'd be a scale factor of 1/2 to make it smaller, because they're related through a scale factor of 2, but we need it getting smaller, so that's why 1/2 is the best answer. So that way it gets smaller. 2 would make it get twice the size, so it would get bigger. The next one, same thing. It says that A is equal to J, and angle C is equal to L, and then related through a scale factor of 2. Determine if they are congruent or similar, which of the following is correct. We have angle-angle similarity. So they have angle-angle similarity. Once you have two angles the same, you know that the third angle is the same, and you can say that they are similar. So yes, they're similar, and they're similar since all angles are congruent. They're not congruent. Congruent would mean same size, and they're clearly not the same size. This one said the triangles are similar since all the sides are congruent. Well, all the sides aren't congruent, so that's not correct. And this is the answer. All the angles are congruent and the sides are proportional due to dilation. Yes. What point on the number line is 7/9 away from the point -3.6 to point 10? So this is one of the more challenging ones. So you have a number line, you have a point at -3.6, you have like 0 here, and then a point at 10. It wants to know what point is 7/9 of the way to 10. So first step, we need to figure out the distance between these two. So the distance between -3.6 and 10 would be 13.6. So you have 3.6 here plus another 10. So the distance is 13.6. What is 7/9 of that though? That's our next step. Is to figure out what 7/9 of that distance is. 13.6 times 7 divided by 9, and that would be 10.57 repeating. I'm going to keep that number in my calculator so I don't round. Okay, so we need the point that is 10.57 away from -3.6. So I'm going to do -3.6 plus 10.5777 repeating. Just keep it in the calculator. And this is where my point would be. So 6.9777 repeating. The point written as an improper fraction is blank, and the decimal rounded to the nearest hundredth. So the decimal would be 6.98. And as an improper fraction, I'm actually going to use the calculator to change it into an improper fraction. Let's see. So I have these buttons here. I'm just going to click them and see if I can get it to work. 6 and 44 over 45. Let's see if I can click it one more time. And there's the improper fraction, 314 over 45. And you can actually do that in the simpler calculators as well. So if I was using this calculator, which is what you probably have on testing, you could do 7 divided by 9 times the 13.6. You get that 10.57 repeating number. And then I would add that to the 3.6 negative, and I get this number. And then to turn that into a fraction, I'm using the buttons down here. And I'm just going to do second this. I get 6 and 44 over 45, but it wants improper. So I can do second in this button, and I'll get the 314 over 45. So there's my improper fraction that I got there. Okay, for this one, given this quadrilateral with these points, classify the type of quadrilateral. So for this one, you would need to graph. You are going to be given graph paper for the EOC. So we get -3, -4, 1, 2, 3, 4 right here. 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1, 2, 3. And then I'm just graphing here. 1, 2, 3, 4, 8. Okay, not a kind of a weird shape here. See, remember, I'm wondering what quadrilateral it is. I'm looking for like either parallelogram, rectangle, square, rhombus. In this case, it's not any of those. It's actually a trapezoid. So in a trapezoid, it has one set of parallel sides. So because I have one set of parallel sides, we have a trapezoid. So that is what it's looking for. Quadrilateral is a trapezoid. Okay, next question. This one's a bit of a challenging one as well. What are the coordinates of the point that partitions segment AB into a ratio of 2 to 3? So here's what I'm looking for. 2 to 3, I need to figure out, like if I was to break this up into 5 pieces, there's 2, 1, 5 pieces, I want to know what point 2 to 3, 2 parts to 3 parts, and I want to know what that coordinate is. So what we're going to do is we're going to take that coordinate. This looks like it's at -4, 4. And then the second coordinate is at, oh my gosh, it's hard to see. Oh, I can look at where it's 6, -5. Okay, so there is an equation for this. The equation for partitioning a line segment, it looks like this. So you have your ratio, which is A to B. And then the fraction of the way here would be A over A plus B. So in our case with 2 to 3, it would be 2 over 2 plus 3, which is 2/5 of the way to the next point. So that is important for our equation. So we got that. So we need to find where it is 2/5 of the way there. Now, the equation looks like this. Our x-coordinate plus this ratio, so we'll call that, it'll be 2/5 in our case. And then it'll be x2 minus x1, the distance from the x's. And then we have y plus, in our case, the ratio, which is 2/5, y2 minus y1, the distance of the y's. So in our case, this will be x1, x2, and this will be y1, oh, sorry, x1, y1, and x2, y2. This should be a 1 and a 1. Okay, so now we can plug our numbers in. So our first x-coordinate plus 2/5 of the way, distance of the x is 6 minus -4. And then we have our y1, which is 4 plus 2/5. And the distance between the y's would be -5 minus 4. Okay, and now, I'll zoom in a little bit too here. I'm just going to solve this out. So -4 plus 2/5, and this would be 10. Okay, -4, 2/5 times 10 would be 4. And then 2/5 of 9. 3.6. Be -3.6. Make sure I get the negative in there. Okay. So then this would be 0. 4 plus -3.6 would be 0.4. And that is actually the answer. So that's what we put here, 0 and 0.4. So as you can see, a bit of a challenging problem. We're going to practice this again in a second. Okay, next one, it says circle A has center located at 2, 2 and contains 0.44. So circle A, center at 2, 2, contains 0.44. Find the value of the radius. The value of the radius squared would be what? So the radius would actually be the distance between those 2 points. So we need to use distance formula. This is on your reference sheet. Yeah, x1, y1, x2, y2. And then I'm going to plug it into the formula. 4 minus 2 squared plus 4 minus 2 squared. 4 plus 4 is 8, square root of 8. But it says radius squared. So my answer was square root of 8, and I just square that, and I can get 8 is what it wants here. Okay, next one. Okay, this is another practice one with partitioning the line segment. So again, I'm going to take this ratio 1 to 2. So I need the point that's 1/3 of the way there. So I'm just doing 1 over 1 plus 2, which would equal 1/3. That's the ratio. And then I'm going to set it up just like I did the other problem. So x1, y1, x2, y2. I need my x coordinate plus my fraction there. And then the distance between the x's, so 2 minus negative 4. And then for the y coordinate, 2 plus 1/3 of the way, the distance between the y's. And there we go. Now I'm going to solve. I get negative 2, and what else do I have here? I get 1 2/3. Believe the answer key for this one, you need an improper fraction, so I'm going to multiply then add to get this to an improper fraction. Negative 2 5/3 is what would go here. Okay, and the next question, circle A contains a center and contains a point at 4, 4. Write the equation of a line tangent to circle A at 4, 4. Okay, so circle centered at 2, 2. It has a point at 4, 4. And there is a line tangent to this circle right here at 4, 4. It wants to know the equation of this line. So first of all, we need the equation of this line, which would be perpendicular to this. So the radius is always perpendicular to the tangent. So let's see the equation of, or the slope of this line. Let's do slope, which is y2 minus y1 over x2 minus x1. So that would be 4 minus 2 over 4 minus 2, 2 over 2, which is 1. Okay, so the slope of this is 1. And then a line perpendicular to it, we need a negative reciprocal. So 1 over 1, the negative reciprocal will be negative 1 over 1. So the slope of this perpendicular line is negative 1. So we have an equation that would look like this. Y equals negative 1x plus b. And we need to determine what the y-intercept is of this line. So we can choose a point on the line, like 4, 4, to plug into this to find b. So I'm going to do that. So I'm going to use this point, 4 equals negative 1 times 4 plus b. And b equals 8. So y equals negative x plus 8 is the equation of the line tangent to this circle. So that's what I'm looking for in the answer choices. It looks like it's this answer. And if I rearrange these, I'm looking for something that equals this. This would not rearrange to that. Neither would this. Nope. This actually would. I could subtract the x on this side to put it over here, and that would be the same equation. And then the other ones don't rearrange to that. So those are the two correct answers. Okay, and last but not least, this one right here, given this parallelogram with these points, find the exact perimeter and area of the parallelogram and do these problems. Let's see. Okay, so I'm going to quickly just graph these points. Okay, E is at negative 1, 5, 1, 2, 3, 4, 5. Here we go, E. F is at 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. G is at 4, 4, 1, 2, 3, 4. And H is at 1, 1. Okay, it's clearly a parallelogram. Okay, and then choose all the correct answers below. It looks like I need the length of each of these sides. So I'm actually going to use Pythagorean theorem to find the length of these sides. And because of the parallelogram, once I find the length of this, it'll be the same as this. So here, 2 by 4, 2 squared plus 4 squared equals c squared. So I get square root of 20 equals c. So this is square root of 20, and so this would be square root of 20 as well. And then here, for this length, it looks like it's 3 by 3, so 3 squared plus 3 squared equals c squared. So I get square root of 18 equals c, so that would be the length here and the length here. And now I'm going to go through the answer choices and see what makes sense. So EF is saying 20, so nope, that would not be right. I'm going to skip the area for right now. HE is square root of 20, that's correct. FG, is it square root of 20? Yep. Perimeter, I'm going to skip that for the moment. GH is not square root of 20, and EF is square root of 18. Okay, so then for perimeter, I need the distance around this shape. Let's see, square root of 20 plus square root of 20 plus square root of 18 plus square root of 18. You know what I'm going to do? I could simplify these, or I could find out what this equals in a decimal and I'm going to find out what this equals as a decimal and compare it to what these equal as a decimal. So that way I don't have to do all this simplifying. Let's see. So square root of 20 times 2 plus 2 square root of 18. I get 17.43 for the perimeter. And then for area, it would be this height. Ooh, I'm not ready to do all that. It'd be the height times one of the bases. Let's see, I could do it, but I'm not in the mood to do all that. Let's see, so the perimeter is correct. Yes. And for area, I can tell you this area is not correct. And I believe that equals this times this, which wouldn't be the formula. The formula for area of a perimeter is actually the base times the height, but it would have to be a perpendicular height, not a slanted height like this. So no to that one. Okay, and that is all for this video. Then we'll have video number 5 coming next. Video number 5 linked below, and we'll see you there.